Good day, scholars. Welcome to Ace to Test Academy. Please kindly subscribe to my channel and make sure you like this video and don't forget to click on the notification bell. Thank you. We'll quickly do the first part of this chemistry practical, which is volumetric analysis, which we know as titration, and this here will be according to the specimen given. It's going to be acid-base titration. So we'll be looking into possible questions and answers. From the specimen, I generated this question, actually predict this question and generated it out. So the question says A is a solution of 0.2 mol per dm of VCl, while B is 0.5 gram of Na2CO3 x H2O per 250 cm cube of solution. Put it into the burette and titrate it. You can read the question here. You have to tabulate the table, and from the result you have to calculate the concentration of B mol per dm, and you have to find the X, and this third one, percentage of water of concentration, is possible it's come up because of the X H2O in the B. So here is the table I formulated. You don't have to perform the Pascal. Pascal is not really necessary. Your table is what is important. Your trend on the table is what is very important. I actually use 24.7 as my end point. Though your end point that your teacher will get might be different from this. So this is just a sample. So it depends on the end point that your teacher gives to you. So your end point of your teacher, you're expected to get something close to it, like for me now, assuming the end point of the teacher is 24.7. So if I got 24.6, still correct. If I got 24.5, still correct. And if I get 24.8, 24.9, it's still correct. So I have to make the table. So first and foremost, I indicate my volume of pipette used. Volume of pipette used 25 centimeter. That's the volume of our pipette. So it may be 20 centimeter square also, centimeter cube rather. And indicator used is material range because it's stronger than a weak base. So you write your rough here, your first titer, second titer, third titer, then initial, final volume of air used. So first thing you write, so it can be very easy for you. Just write the volume of air used, what you want to formulate. You need only one titer value. You can use the one that your teacher has done because that is more perfect than the one of the student. So assuming the one of the teacher is 24.7 now. So the rough, I wrote 25. So my first titer I wrote 24.8. Then my second I wrote 24.7. My third I wrote 24.6. Knowing in my mind that if I add everything together and divide by 3, I'm going to get this 24.7. Do you understand now? So my initial reading, I fill it up again. This 25, I didn't write my 25 here. I had to fill it up again to 0. So that's why 24.8 plus this gives us 24.8 here. So now brought this down here and titrate again. So our white point is now 49.5. So if you add 24.7 plus 24.8, you are going to get 49.5. But this thing is that it must not exceed 50 because the whole thing is 50 and at 50. So I have to refill again to maybe 5. Can refill to 10. Can even refill to 0.00 again. But I refill down to 5. So if I add it together, and I'm going to get 29.6. That's it. So it's as easy as that. So we are asked to find the average volume of air used. So our average volume of air used, just add the first titer, second titer, and third titer divided by 3. And here is it now. So I had it a mixing 4.1 divided by 3. That's 24.7. So we are done with A. Now moving to B now. BI says look for the concentration of B in mol per dm, that is the molar volume of B. Our formula is going to be CAV over CBVB equal to NA over NB. So the C there is concentration and the V is the volume. So the C is concentration of the acid all the A are of the A's, while all the B are for the B's. So the N, that's the number of mole. Here is the question. Here is the question. So when the question is balanced, you check the mole ratio. The mole ratio of the acid that this here is 2. That's how we have the 2 here. And mole ratio of the base is 1. That's it here. So our mole here is in the question. If you check the question, it's in the question. That's the mole of acid. Concentration of acid multiplied by the volume of acid. That's how volume that we calculated. Here is concentration of B that we have to find, and here is the volume of pipette. That pipette, that's where we pour the base. Then that's the volume of the base. So that's the volume of pipette we determine the volume of our base. As we use 20 points, just the same cube, I'm going to use 20 years, and now I use 25. So I use 25 here. So if you cross multiply that, is 20 0.2 times 24.7 multiplied by 1, that's 4.94. Then 25 times 2, that's 50 times CB, that's 50 CB. If we divide both sides by 50, that will be 0.0988 mole per dm cube. So the concentration of B mole per dm cube is 0.0988. And take note, concentration in mole per dm cube that we have to find is with what? Is the molar volume. Do you understand? But if they say in gram per dm cube, that's what? That's the molar conc. This is molar. I made a mistake. The concentration in mole per dm cube is our molar conc, while the concentration in gram per dm cube is our mass conc. Please take note. Back to II, value of X in Na2CO3 XH2 in solution B. That is the value of X in hydrated Na2CO3. As hydrated is contain water, and if I say anhydrous, it does not have water. Before we can get it, we should have used the normal calculation of molar mass, but we will not give the molar mass of this because we don't know the value of this X, though it's 10, but they won't tell you guys, so we don't know the value of this X, so we can't look for, we are not given the whole molar mass, so we can't use that. So we have to use the formula for calculating water crystallization. So now that's mass conc of hydrated salt, that's the one containing water, over molar mass of the hydrated salt. Yeah, it's equal to what? A mass conc of the anhydrous salt over the molar mass of the anhydrous salt. Now we are not given the mass conc. We are not given the mass conc of the anhydrous salt, but we are given the molar conc. We've calculated it, and the molar mass of this is the molar mass. You calculate, you will be given this one. Though I did not write in the question, but you will be given. So that's I calculate. That's the molar mass is 106 gram per mole. So to get our mass conc of the anhydrous, so this is the formula. That's molar conc. Our molar conc is equal to mass conc over molar mass. So if you cross multiply, that's mass conc equal to what? Molar conc times molar mass. That's it. That's molar constant. This give us this. That's 10.5. So that is 10.5 gram for anhydrous. Take note, it's for anhydrous, the one that does not have water. It's for anhydrous salt Na2CO3. Now we want to calculate the one for the hydrate, the one containing water. Now let me show you something in the question. Take a look at this, please. B is 7.15 of Na2CO3 XHO per 265. No gram per volume is mass conc. So this one is what? 7.15 per what? 250. Do you understand? So we are going to quickly like, so if 250 is equal to 7.15, then 1000 cm cube equal to dash. Do you understand now? Equal to X. Now here is it. 250 cm cube give us what? 7.5 gram, while 1000, that's constant, give us what? X. Now if you cross multiply, that's our X will be 1000 multiplied by 7.15 all over 250. So if you press the calculator and divide everything, you get 28.6 gram. Exactly 28.6 gram. And we've gotten the mass conc. So we are going to look for the molar mass of the hydrated salt also. So here is it. Because we did not know the value of this X, so you can multiply this by S. That's 106 plus 18x. And here is the formula for calculating it. It's that same formula. Let's input it. This is the formula. So our mass conc of hydrated salt, one container, that's 23.6 that we got. Here is it. So add the molar mass of everything, that's 1.106 plus 80x. Here is it. And one of mass conc of anhydrous salt, yes, that's 10.5, while the molar mass of anhydrous salt, that's 106. Now if you cross multiply, that will be, if you press the calculator, 10 times multiplied by 106, that's 113 plus 18 times 10.5 give you this. So 20.6 times 106, so I'll give you this. So if to collect like 10, this one will be subtracted from this one. So that will be 198.6 divided by 198, that's 10.15. So you approximate it to 10. We all know that 10, if we see the specimen, it is 10. So that's what 10, or approximate to 10. That's the value of x. Yeah, let's go to the last question. The percentage water of crystallization. So you can do this one in two ways. Yeah, like I said, you can actually do it in two ways. The formula is mass of hydrated minus mass of anhydrous. Mass of hydrated is the one containing water we calculated, and mass of anhydrous is the 10.5 also calculated, over mass conc of dehydrated, the same thing. I mean, this one is also the mass conc. I can also call it mass here, since the three are mass conc, so you can use mass or mass conc. Don't let this one confuse us. It's the same thing. Now multiply by what? 100 over 1. That's percentage. So if minus, that's 20.6 minus 10.5 all over 20.6. Now we are going to get 3.28. So in one decimal places or 3 significant figure, I approximate to 63.3 centimeter. I mean 3%. So this is the second way you can do it. Here is the second way, or here is another formula. That x is to, that is the water over everything together. That is the water. This is the water now. Then this one is everything, both the salt and water. Now multiply by 100 over 1. So no, we've already gotten this x. So we place the x by what? 10. We've gotten 10. That's 10 times 18 all over 6 plus. Also now 18 is h2 is 18. 6 plus 10 times 18, that's 180. That's 6 plus 106 plus 180 also, that's 286. So 1 is divided by 26 multiplied by 100, that's give you 63, or approximately 63. So that's it about chemistry practical, the first part. That's it. That's all. It's very simple. So there is a possible question that can actually come out. The other ones, like you've calculated the mass conc, you calculated everything inside this place. They can ask for the mass conc. Though I didn't precise the question, but during the process of me solving the second question, we've calculated most of the mass conc, so you get the idea on how to calculate the mass conc. Thanks for watching. I hope you learn a lot. Please don't forget to subscribe. Please don't forget to subscribe and like this video and share to your friends. Have a good day. I wish you success in your exams. Bye.